In previous session, what we have did was we created a binary tree. After that, we have printed the binary tree in pre-order fashion. We had explained the recursion, how it insert will work, but we have simply wrote the code for pre-order but did not draw the recursive tree. So now let us do that one. So we got the correct output, and now let us see how pre-order will work. This is our tree: 10, 5, 20, 2, 7, 15, 25. This is binary tree. Then pre-order is 10, 5, 2, 7, 20, 15, 25. In order this is this one, and post order is this one. Let us focus on pre-order first. If I understand pre-order, then I will definitely be able to understand in and post order. So imagine this is a tree. As I said, this is 10, right? What you do is, first of all, let me draw all the elements of the tree. That means let me just draw all these things. This is 5, right? And let me draw it properly. This is 5, right? This is what? This is 20, and after that we have 2, 7, 15, 20. 2, this is 2, this is 7, this is 15, I think. Yes, this is 15, and this is 25. That is 25. Okay, now what I do is I will just copy the code and paste it here, so that while while understanding this how it works, you can't simply understand without code, right? Let us paste this code here, and let me make it somewhat bigger. So I will keep here to 26. Okay, now it is perfect. Now here pre-order, the first one is what I am sending at pre-order is root. So 10 is a root node I am sending. Actually to be precise, root node I am sending. Root node has 10 in it, and it has left and right child. That is what it is. But I will simply take it as a, like, to represent, I will take it as a 10. Like, I am passing the root node. If p isn't equal to null, means if it is not null, definitely it is not null. It is not null. It is not null node. Actually, there's some data in it. So it is true, right? Then you go and print the data first. Means print 10 first. So I am printing 10. Okay. After that, what you need to do is you should call for left child. Okay. P, it is a p is at root, right? This is root. So this is root, and p is initially at root. P left, I am sending pre-order p left, means I am again calling this function. This is a recursion. So it is a local call in this function, means it is like calls are different for this one and this one. I will explain you how it works. Pre-order p left means I am sending 5 to this function. Okay. After sending, if p isn't equal to null, yeah, it is not equal to null, then you print. Okay, I am printing 5. After that, again call the p left. Okay, again if I call, I will be calling 2, right? Again it will come here, it is not null, again print the 2. Again you call for left. Now when you call for left, means 2's left you are calling, means what you are calling, you are calling for null. So you go here, since p is null, then this function will this function what I called, right, this is completed, means this will be not executed. So we will come to end of the function, like end of this recursion call, that is when p is at 2, right? At this time it will when we call for p left, means now p is at p left, that is 2's left. At that time this function will not execute. So what it does, the function will be completed, like it will be completed, then we will be where, that is what the question here. We were at 2, right? We came to left, which is null. Okay, now this function is finished. Then you come back to this point itself. You will be coming back to this point itself, because see, you called something and that function was finished, it's simply finished. Then what you did was you should come back. That is how recursion works. You should come back to the next step, previous step. You should not go to like top of the root, directly top of the recursion tree directly. So you will come back to the second one, right? Because there are again this line has to be executed for this when p was 2, right? At this time p left was executed, so now p right has to be executed, right? After that p right will be executed, so 2's p right is again null, so it will come here, this will be failed, and this function will be like again it will be over. After that it will come back to 2 itself, right? After that we are completing this whole function, means I am going back. Whenever the function completes, right, it will go back, or if any function returns, right, as I explained in insert, it will go back to its previous call. So previous call was what? 5, right? 5. Let me erase. So at this time where p will come, p will be coming back to 5. Okay, it came back to 5. Now see, it has executed when p was at 5, it has executed p left, it has executed. Now p left has given its given some value for it, like p left, this is a p left of 5, right? This has been executed. Actually this will be not executed at first, so just this will be not executed, and still the control is at 2. Now it came back to 5. 7 is not executed yet, means 7 is not printed yet. Now what? I think you are understanding this one. Again this will be p left will be over for 5th route, that is for the for 5. Then this line has to be executed, p right. Okay, it will go for p right, that is 7. Again this call will be done, so 7 is not equal to null. Again you need to print, the first statement is print, then go for p left. Now you go for p left, so it is null, right? But you are calling, however it is null, it is you, but you should call p left means null, you are calling preorder null. Again this will be not executed, so it will come back to this position without doing anything. Like, I think you are understanding this one. After that for 7 this line is executed, this line was executed, now this line is left, so I should execute this line, but still 7 right is also null, so go back here, null, so this will be not executed, so this function is finished, so it will come back to 7. After doing this there will be nothing, then it will come back to 7. Now I am in 7. For 7 I am, the control is at last line, means that I have already executed last line, then function will be over. After function will be over, you go to the previous call. What was the previous call? Previous call was 5, so I am going to 5. P is 5 now. Till now I am not going, I did not went yet to 20, 15 and 25. I now I am at 5. So for 5 last line is completed, right? Last line was completed, just now we have completed that. 7 came, the 7 came because we executed last line, right? So it will be over, right? Again this line will the 5 will reach this line, so it will reach this line, means function is finished. Then it will go back to previous call. Previous call was 10. So for 10 you till now you have called p left, right? P left, that is what you called till now. P right was not called, that means it is not reached to that next line yet, but now it will reach. When it reaches p right, so p right, it will p right is what? 20. So again call will be taken. Let me erase this one. Now 20 now again, now 20 has to be p right, means I am at 10 and last line has to be executed. P right was 20, so I will call for 20, so it will be 20, so it is not null, right? It is not null, so you print it. So I am going to print it 20, I am going to print it 20. After that I will call for left, means again for 20 I will call for left, right? For 10 the third line is not completely executed at all, it is still like it is in the recursion mode, but 20 will call for left. So left is what? 15. You call for 15. Again 15 will go here. If it is not null, again it will come, it will print 15. Then for 15 left child will be called. Forget about 20 now. 20 is in recursion yet. We should go back now. But now 15 left you have to see. 15 left is what? Null. So null, this will not execute, nothing will be executed. The function in this line will be ended. Next, for 15, I have to go for 15, I have to go for last line, that is third line. Right child is null. Again, if the function is called null means it is not, it is null. That is why this function will be not executed, this if statement will be not executed. Then the function reaches the end of the recursion. For this 15, I am at 15. So after 15, you go back to 20th call. Where is 20th call? 20th call was executing p left child, right? Now it has to execute p right child. So it will execute p right child. So that is 25. Again 25 will come here. Again it is not null. It will be printed like 25 will be printed. Then again left child will be called, which is null. Right child will be called, which is null. Again function will go back to 20, right? It will go back to 20. Again for 20 we have reached the end of the loop. Again the control will go back here. So for 10 we have executed this line, right? When we came here only we were executing this line for 10. When we came here, at that time only we are executing for 10. So this will be finished. Again the complete recursion was finished. So our answer was 10, 5, 2, 7. So you can observe this is a pre-order. This is what the result we needed. 10, 5, 2, 7. 10, 5, 2, 7. 20, 15, 25. 20, 15, 25. Even if I execute this code, now I will ask for, again I will take the input as like 7 elements, that is 10, 5, 20. I am just giving the elements into, feeding elements into 3, 15 and 25. Now I should get 10, 5. So 10, 5, 2, 7, 20, 15, 25. That is why it works. So Inorder is similar to this one only. Let me change here how Inorder will work. Actually Inorder, this slight change you need to do for Inorder, right? So let me do that one. Let me erase this one. Let me show how simple Inorder looks after if you learn preorder. I will change the code here. The code is this. P data I will not print here because Inorder, right? I have explained you how Inorder works in the previous class only, like how you should draw the line at the right side, down, and left side, and how you should print it. Now cout I will put at the between, like I am putting line in between while traversing, right? For Inorder I was putting like this. So similarly cout should come at between. So similarly the same thing will work. Again if I will explain for Inorder, then I will write the code. Then I will not explain for Postorder. You can only trace that one, so that will be easier and you can learn through that homework. 20, then 5, then this is what 2, and this is what 7, and this is what 15, and this is 25. Okay, 15, 25. Okay, now 20 will be sent. There is root will be sent. You go for left child. Oh, I will go for left child. Again 5 is there. Again call for that one. It is not null. Again go to the left child. So I am still here in this line. Okay, left child of 2 is null. So this will be not executed, right? So if it is not executed, this line will end. This line will end, and we will come back to when function finishes, right? It will go to the next line. That is what the important thing you remember. Here P2 left child was null. So when I send it null here, this function was false and this statement was false, so function ended. At that time the control will go to the next line. The next line is what? 2. So you print 2, right? I am at 2, so I am going to print 2 here. After that right child, you go for right child, means 2's right child, it is also null. So this if statement will fails, so the control will move to the come back to here 2. Okay, For this 2, I reached the the third line, and I already completed this line, right? If I complete, then if statement will end. If statement ends, then what? Then if means the control has ended. Control has ended, that means for 2 everything is finished. So now what was the previous call? For after before 2, what was the previous call? That was 5. So go back to 5. You go back to 5. The for 5 you had already executed p left, right? Now come back to the next line. Next line is what? P data. So you print that p data, that is here it is 5. After that you call for p right child, means for 5 afterwards you go for right child, that is 7. So you pass 7 here, so it is not null. Yeah, it is not null. Go to the left child, that is null. So this function will end. Go to the next line, that is p data, that is 7. Print 7. After that what? You go for right child. So it again this function will be not executed. So if you go on doing that, you will get this one: 2, 5, 7, 10, 15. You have to trace back. You have to learn how to trace back the recursion. Tracing forward, like going down the recursion tree, is easy, but you should so for that reason we are drawing trees, right? Recursion trees is drawn because just to know the what was the previous node, previous call. Just for that reason we are drawing in this tree, in this way itself. So that is how post order will be done, and in order will be done, and post order you can trace it there. And I will give you the output, how it should look like, right? This is 5. Actually this is 5, and this is what post order. For post order I will be drawing like this: 2, 2, 7, 2, 7, 5, then 15. Okay, 15. This is 15. So my solutions for in order is 2, 5, 7. This is 10. Then 15, 20, 25. So I should get this one. I will just copy here. I will simply change this to in order. So that will be better, I think. Or else what I do is I will write all pre-order, in order, and post order, and I can show you that by displaying. Okay. I will simply copy this twice. Then what? I will change the function name to in order. This is in order. When in order, and for in order, cout should be what? It should be at the second line. So I am writing at second line. For post order, it should be in last line, right? It is obvious. So you can trace back this post order. Post order. So post post order. Then I should call, right? For all I should call. Let me give cout end line. Let just differentiate the orders. Then pre-order, I will call it as PO in order. First in order. Then I will send a root here. Then cout again I will give it. Then again post order. Then root I am going to pass it again. So if I print, I should get the same value, right? What? Okay. Now what I do is I will give same input, that is 10. There will be 7 elements. So they are 10, 5, 20, then 2, 7, 15, then 25. So all 3 are printed. Let me show the result. 10, you can compare 10, 5, 2, 7, 20, 15. Then 5 in order, 5, 2, did I write 2? 2 should be coming at first, right? So why this is happening? 5 is coming at first, but 2 should be coming there now. It is in order. Okay, 2, 5, 7. So it is exchanged. So everything is, so something mistake I have did. Let us see the code. What was the mistake? I'm printing in order, right? Okay. So while calling, I should call in order, right? It's a recursion. I should call in order, and even for post order, I did that one. So that is the problem when you copy paste. Post order, post order, right? Now it should work. So I will send again. I'll give the same values, that is 7 nodes I have. 7, okay, 5, 10, 5, 20, then 2, 7, 15, then 25. So if I print, it should work well. 10, 5, 2, 7, 20, 15, 25, 2, 5, 7, 10, 15, 20, 25, 2, 7, 5, 15, 25, 20, 10. Yeah, it is working. This is how now display, you can display the tree. Next we are finding the count, sum, and these all things, and in next video we are covering those things. The most important thing that you should do is writing tree. That is so much important. Like drawing recursive tree is the most important thing. So if you do that one, recursion will be easy. If you learn recursion, dynamic programming will be easy. If you learn dynamic programming, then solving any competitive problems in your internships, or even in any coding platforms, any competition, that will be easy. Thank you.